Hello everyone and welcome to Azure Cosmos DB Conference 2025. I'm Divakar, currently working as a technical architect at Flyerssoft. I have been in this field for more than 10 years. I have spent most of my time working on the distributed systems, but lately it's been AI because these days, whenever I have a conversation with client or community member, they all ask for the same thing. They want to have AI in the solutions. Um, but that is where the real fun begins, right? So it is no longer a straightforward mission. So now you need to think about RAG, retrieval augmented generation, just to give the LLM with a better context and also to get back a better response. Also, you need to know about the embeddings just to capture the semantics of the data, and also you need to work with semantic catching, so that you don't always interact with the LLM for each and every single request. You now need to work with vector search, hybrid search, like getting the best of both worlds, like doing the vector search plus the keyword search. And also now you need to provide the additional context to your LLM, like the chat histories, to get the better response. And obviously you need to now work with agentic workflows, like multi-agentic workflows. But that is not it, right? So building an enterprise grade application is a lot more than that. So now you need to address the scalability, availability, high performance, cost efficiency, and also the latency. So you need to address all these challenges to build an enterprise grade application. So there is one solution to this for you to build this enterprise grade application, that is Azure Cosmos DB. Obviously, because we are at the Azure Cosmos DB conference. So what we are going to see today is how Azure Cosmos DB is going to help us in the AI workflows, right from doing the knowledge retrieval till getting the insights out of these data with the help of Microsoft Fabric. What I'm gonna do is I'm gonna divide the session into two halves. In the first half, we are gonna see everything about the knowledge retrieval, and in the second half, we are gonna see how Microsoft Fabric alongside your Azure Cosmos DB can bring some insights out of your data. So let's start with the knowledge retrieval. So before getting into the concept of retrieval augmented generation, so let's address what do you mean by augmented generation. So you have a client application which sends some queries to your application layer. Within your application, you either hard code your existing prompt with additional context, or you dynamically change the make a modification to your existing prompt, and then if you send that to your LLM just to provide additional context, and if your LLM send back you with a response, that will be sent back to your client application. So by doing this way, you are augmenting something, augmenting an information inside the prompt, and you are sending it to the LLM. So this is what they call it as augmented generation. So let's see an example how this works. So you go to your Azure AI Foundry, ai.azure.com, and go to your chat playground and ask about yourself. Unless you are a celebrity, it is not gonna know about you. So what you are gonna do is, like, you are gonna modify the system prompt by providing it with an additional context. In my case, I'm gonna explain about myself and I'm gonna apply these changes. And when I'm gonna ask the same question again, it is gonna respond in a better way because now it has the additional context. Now we have augmented additional information into this prompt. So that is why you could see a better response now for the second atom. So now let's get into the retrieval augmented generation. In addition to what we have seen earlier, we are just going to have a knowledge base in this flow. So whenever there is a user going to ask you with a query, it reaches the application layer. And now in the first place, we are going to check in our knowledge base if there is any relevant information about it. And if there are any relevant information about it, we are going to return it back to our application, and those relevant informations are going to be augmented as an additional context to this prompt and then sent to the LLM, and we get a response from the LLM in a natural language way. So this will be again sent back to the client. So this is what they call it as retrieval augmented generation. So let's see an example on how this works. Every one of us should be familiar with the ChatGPT. So what I'm gonna ask is about my current internet bill for the Act FiberNet that I'm using. So obviously it is not gonna be aware of what is my current bill is about. So it is just gonna make use of some tools that is it is already having, like the web search, and it is going to find what are the different plans and what are the nominal fee for those plans. But what I'm going to do now is I'm going to add an invoice PDF, and I'm going to ask the same question again. So now it is going to respond back with the correct amount that I need to pay. So this is what retrieval augmented generation means. So you retrieve some information from your knowledge base. That could be an unstructured document like the PDF, or it could be a database as well, which we will see in a bit. So then you augment them into the prompt to provide additional context to your LLM to get back a better response. So now we are going to implement this RAG concept with the help of Azure Cosmos DB. So inside the Azure Cosmos DB, we also have this native vector search capability. So that is what we are going to make use of today. So you have a client application, user sends in some query to your application layer. In the first place, what we are going to see, what we are going to do is we are going to convert this user query into embeddings by interacting with the OpenAI model, the embedding data model, and then get back the embeddings from it. And with these embeddings, we are just going to cross check within our vector database to retrieve the relevant information back from the Azure Cosmos DB. So now this retrieved information is augmented into the prompt and sent to the LLM. Now your LLM is gonna respond back to you with in a natural language way, which is gonna be sent back to your client application. So this is how the vector search works behind the scene in the Azure Cosmos DB. And for you to do this, this is the query that you could do. Say suppose you have a container defined for storing your embeddings alongside your metadata. You could do the vector distance function to calculate the similarity score between your embeddings that you stored in your database and the embeddings that you got from the user query. So comparing these two, you just need to get the top probability from this based on the similarity score. So that will help you to find the relevant information back from the Azure Cosmos DB. You could also perform hybrid search on top of it by doing the vector distance calculation, and alongside that you can also now use the full text scoring to provide you with more relevant search result. This they call it as reciprocal rank fusion algorithm, and this is the query that you could use to perform this hybrid search. But not always the user is gonna ask something related to the semantics, right? So sometimes user could ask queries related to what is the total number of records that I have, or what is the aggregation kind of a thing, or my past 10 bookings, please list down my past 10 bookings. So these are some of the possibilities and user could ask. So for those scenarios, what you could make use of is natural language to SQL query conversion, in which like you have a client application, a user is gonna send in some query. In the first place, you are gonna make use of some engine that you have, like natural language to SQL engine, that converts this natural language into SQL query. With this SQL query that you received from this engine, you are gonna make a search against this Azure Cosmos DB database to retrieve the relevant information back to your application. And this retrieved information is again augmented to the prompt, sent back to the LLM to get you with a response, better response, which will be finally sent back to your client application. And there are n number of ways you could implement this NL to SQL engine. What I'm gonna use is the Cosmos DB SQL engine. So we are gonna interact with two endpoints with which we will be able to get the SQL query. So in the first endpoint, the request that you need to send is the database ID and the container that you want to search with. What you're going to get back is the service URL, alongside you are going to get a bearer token. So with these two information, you now need to make a second API call to that service URL that you received as a response in the first endpoint call. Alongside, like, you need to pass the bearer token as well. And now the request payload is going to be your user prompt. So say suppose your user query is like, find top 10 bookings of the passengers. Say suppose like this is an ID. Now it is going to be converted into the SQL query, as you could see here, and alongside that you will be also getting an explanation for that. So now you're going to make use of the SQL query against your Azure Cosmos database to retrieve the relevant information, which will be augmented into the prompt to get a better response back. So by this way, you could handle all the user queries that you might expect in your chatbot. So with this, we are done with the knowledge retrieval part. So let's move on to the Microsoft Fabric integrations. So for those who are new to Microsoft Fabric, it is an unified SaaS solution for analytics. But we are moving towards the direction of translytical, datalytical, like, because we also have the native database support inside the Microsoft Fabric, alongside the different personas that we have, like the analytics, data factory, real-time intelligence, Power BI, inside this Microsoft Fabric. All this were possible with the help of one lake, which acts as an one drive for the data, and all the different personas that you have within this Microsoft Fabric, like data lakes, data warehouse. All these are perfectly optimized to work with the open delta packet format, and that is how you could pull some data into the one lake. Like, if you want to pull in some data into the one lake, it should be in the format of the open delta bucket format. But since we are working with Azure Cosmos DB, it uses its own proprietary format. So we need to have a way for you to convert those into a delta bucket format, just to get stored in this one lake. So what we are going to use is database mirroring concept. So there is a Azure Cosmos DB mirroring that you could enable on top of your container. What happens behind the scene is, for the one time, you will pick the data snapshot and put it in the landing zone, and there is a CDC processor called change data capture processor, which does the transformation of your Cosmos DB data into this delta bucket format, and that gets landed into your one lake within the Microsoft Fabric. And that is not it. So whenever there is a change happens to your container, like whenever there is an insert or update happens in your document, that is also captured using this change data capture mechanism, and the flow is as before. So you get inside your CDC processor, and that gets converted into the delta bucket format, and it gets landed onto the one lake. So let's see how to build one. What for this, we are gonna use the Microsoft Fabric. Once you create the Microsoft Fabric, you have your own workspace, and inside your workspace, click on New Item and search for Azure Cosmos DB Mirroring. You need to choose the endpoint that you want to use, create a connection for it, and once you are done with that, you choose the database account that you want to use, and inside the database account, select all the containers that is relevant for you to mirror. So once you are done with this, like, you are done creating your Cosmos DB mirroring, all the data that you had within your existing container will be replicated inside this one lake. And whenever you make some changes to your existing documents, like inserts or updates, that will also be captured and updated in this one lake in the near real time. So now let's see how we can transform the data that we had inside our Azure Cosmos DB to create a view on top of it and visualize them in the Power BI. So this is the query that we are going to make use of to transform our semi-structured data that we have inside the Cosmos DB to find some aggregations, like what are some of the frequently used airlines or frequently visited destinations, sort of all the KPIs that could be related to a travel agency business. So once you are done with this view creation, so you go to your workspace, create a new item, and under the new item, now you need to select the warehouse, provide a name to it, and once you are done with that, you need to click on the data sources. So now we have this Cosmos DB mirroring, which exposes a SQL endpoint. So we are going to make use of that, and inside the SQL query, we are going to run this view, which we have seen already. You are just going to create a view on top of it, and once you view that, you will be able to see the aggregation. So the visualization part is easy. So you need to go to the reporting and click on the report model. Now you will be getting land into the Power BI. You just need to select the fields that you want to visualize, like how am I doing here. So by this way, like, you can find all the different business KPIs that your application would ever need with the help of this Cosmos DB mirroring. So with that, we are done with the Microsoft Fabric integrations as well. We have seen like how Microsoft Fabric, along with the Azure Cosmos DB, can help you to visualize some insights from your data. Um, and with that, we are ready to do our Azure Cosmos DB snap to take away all the challenges, all the different challenges that we had earlier. So it is, you could see that it is not just a database, it is acting like a backbone for you to build the generative AI applications in an enterprise grade format. And thank you for listening to me.